Good evening. Welcome to part 4 of our look at greatest common factors and least common multiples. Tonight we're going to look at least common multiples and how to find them using prime factorization. Now what I found is prime factorization, find least common multiples, is a very new thing for my 5th graders, and so it's going to take some time to show it and get used to using it. But the nice thing about prime factorization is once you know how to do it to find the greatest common factor and to find the least common multiple, it really is the easiest way, especially with larger numbers. It takes some steps and it takes some practice. To start with, let's review what prime factorization is. For example, here I have the number 12. In order to find the prime factors of 12, what I look at is what two numbers can I multiply together besides 1 and 12 to get factors of 12. If I can only use 1 in the number, then that number is already prime and there's really no other need to go down. You already have the prime factors. With 12, however, though, there is 3 times 4, which gives me 12. So 3 and 4 are factors of 12. 3 is already a prime number, so thankfully I don't have to find factors for it. 4, on the other hand, is a composite number, and if you remember from the earlier video, a composite number is a number that has 3 or more factors that go into it. So 4 being an even number, the only even number that is prime is 2. Any even number after that, 2 will go into it, so all even numbers besides 2 are composite numbers. The kids have to remember this as they're going through. If I hit an even number, then it's going to be a composite number and it needs to continue being divided into more factors. In this case, 4, it comes from the factors of 2 times 2. So my prime factors when I get done here are 3, 2, and 2. Now, they're not done at that point because even though I have found the prime factors of 12, I have to display that. I have to show that I have found the prime factors. So after I've written out the prime factorization, I do then have to show the numbers as a multiplication problem. So for example, in this case, 3 times 2 times 2, or preferably even 2 times 2 times 3 to keep things in a nice order. Now you'll notice there are 2 2's, and this is where using our exponents comes in handy. 2 2's is really to be displayed as 2 to the 2nd power times 3. So in the end, the final answer, and I've been trying to get the kids to do this every time, it's not enough, it's not enough just to find the prime factors, prime factors, but it also is necessary to then write them out as a multiplication problem and then eventually as an exponential problem if there are multiples of any of the prime factors. All right, so that's finding prime factorization for a single number. To do a least common multiple, I'm actually going to be comparing 2 or more numbers to find that. And that's what we're going to look at next. So if you'll give me a moment, what we're going to do is we're going to put 2 numbers up, and I would like you to take a moment and do the prime factorization, or at least try to do the prime factorization for those 2 numbers. So in a moment, you're going to see a screen, look at the 2 numbers, then hit pause. We'll give you whatever time you need. You can hit play then. And I'd like you to try the prime factorization, and then if you get it, great. If not, in a moment I'll be back and we'll look at it together. Welcome back. How did it go? Were you able to find the prime factors of 10 and 15? Well, let's take a look. I have them written down here, and in a moment we're going to compare your answer to my answer. Before we start, though, I'm going to ask, did you rewrite the prime factors as a multiplication problem at the end? If not, you're going to want to do that right now. You can pause and we'll come back. If you did, however, let's take a look. You'll notice for 10, I came up with the prime factors of 2 and 5. Rewrote it as a multiplication problem, 2 times 5. You'll also notice and probably say to yourself, but I don't see any exponents there. Well, in this case, we really don't need the exponents because any number, any whole number to the first power is that number all by itself. That's our standard counting numbers. Our standard whole numbers are all in the first power. So if I only had 1, 2, and I only had 1, 5, I don't have to write to the first power. I simply write the number 2 and 5. Had there been 2 of either of them, then I would have said to the second power. For 15, you'll notice we came up with 3 times 5. 3 and 5 are the prime factors of 15. Okay? All right, what we're going to do next is I'm going to show you the two-step process for taking those multiplication problems we just created with the prime factors and turning them into least common multiples. Now, here's the cool thing. When you go to find the least common multiples, step 1 actually requires finding the greatest common factor. If you look back at our earlier video, you'll see that finding the greatest common factor involved finding any of the numbers from, any of the factors from one number that matched the factors from another one that they had in common. So what we're going to do for step 1 is we're actually going to take the numbers that these had in common. Well, that means we're really finding the greatest common factor before we actually find the least common multiple. It's kind of like killing 2 birds with 1 stone. Let's look at it. Okay, so step 1 is find the common factors between the 2 numbers. In this case, the common prime factors. Well, when we look at our 10 and our 15, right away you should notice that the number that they both have in common in their prime factors is the number 5. There's a 5 for the 10 and there's a 5 for the 15. That's a number they have in common. Now, where many people get confused is they'll see, well, there's 2 5s there, Mr. V. What do I do? Do I use both of them? Well, actually, no, because they're common, it's something the 2 numbers share. It's a number that will actually go into or could be divided into both 10 and 15, in this case, the number 5. So when we're looking for that common factor, we're looking for numbers they have in common. When you find them, for every pair, you get 1. So if I have a pair of 5s, I get 1 5. So under step 1, I'm really finding my greatest common factor. In this case, the greatest common factor of 10 and 15 is going to be 5. Had there been 2 numbers they had in common, which we will look at later, then it would have been 5 times that number. But do notice, for every pair, I only get 1. That number will go into both those numbers. If I had given it 2 5s, well, 5 times 5 is 25, and 25 won't go into 10. It's too large, nor will it go into 15. I only get 1. Let's look at step 2.